This conference will now be recorded.
Good morning, friends. Welcome to goonlinetrainings.com. So, we had seen yesterday what is a translation and what is a perspective. And today, let us understand what is partitions and aggregations, right? These are very, very important thing to understand. But implementation wise, very, very easy. It's not very complicated one, very easy one. So let us understand why partitions are important. Okay. So if you see the data, we have more and more data will be available in your fact tables, right? So we knew that you get limited data. Okay. So we're talking about queue partitions and aggregations. Why partitions are important? Let us understand. If you go to data warehouse, in which tables the data is more? So we knew that data warehouse will have lot of tables and you will have more number of dimension tables, right? You will have more number of dimension tables and you will have less number of factor tables, right? If, for example, I have three dimension tables, one factor table, and the factor table size will be very, very bigger because every day you may be getting so much of a data, right? So this may be a dim customer table. This may be a dim date table. This may be a dim product table, right? So all these tables are very, very small and you will have much more dimension tables. And these are linked to fact table. So tell me how much of a data you get every day in Amazon.com sales. Every day 5,000, billion transaction or 5 million transaction, 5 billion transaction. We don't know all over the world. Think about a banking sector. Think about State Bank of India. Think about Citibank. Think about any other bank. How many transactions per day? How many cash deposits? Loan payments. This one, that one. Lot of things will happen. You will get more and more data. More and more data is going to come to your fact table. Clear? So when we performing any kind of an aggregations on that, for example, I wanted to get only 2001 aggregations or 2002 aggregations, 2003 aggregations, right? So it will be very heavy and it will be very, very difficult to perform aggregations on the complete, factor table because the problem is that very, very big in size, large in size. Okay. When you have large in size, the issues with the aggregations. What do you mean by aggregations? Aggregations may be summing, minimum, this one, that one. Clear? I wanted to partition. Partition means filter the data based on some condition. I would like to partition the data based on some condition. So that is the need for, cube partitions. Clear? The first thing is that people would ask you, how do you improve the cube performance? Okay. So by default, we can do fact table partitions we can do. Clear? Because fact table where you will get more and more data. And we can also do the, improving steps at the dimension level as well. So let us understand the fact table, what kind of a improvements we can do. And the dimensions levels also what kind of improvements we can do. So here I'm talking about cube partitions. Let me give you a simple example. I have a big room I have. Okay, this is my room. In the room, I have a lot of balls are available. Clear? What kind of a ball? I have some green balls. Okay, I have some green balls. Blue, okay, like that. All the balls in different sizes, different shapes, and I have a lot of balls are available. Now, this is what, and I have some red balls also available in this. Clear? I have some red balls, different sizes. So I have a lot of balls I kept in this room so that I can sell to the public. Okay, I have blue color balls and small balls, bigger balls, this ball, that ball, lot of things I have it. The next one, I have some, let us say, green color balls as well. Okay, I have a green color. So I'm talking about green color balls which available now. I wanted to ask you one question. What is the question I would like to ask you? Tell me how many green color balls you have in this room. That is my aggregation. I wanted to ask you how many green color balls you have. So what do? You first read the row. Is it a green or red? If it is a green, you count it. If it is red, that is waste. Then go to the next ball, green or red. So when you're going and reading the data may be of red, the data may be of green, the data may be of blue. We don't know. But what is that I need? I need total number of green balls or a total number of red balls or a total number of this balls, that ball. So when you store all the data in a single room, and when you're trying to aggregate, you're unnecessarily you are going to be picking up row by row, row by row, row by row. The row could be any row. The row could be any row, but you need the row with the red or blue or green. Clear? So I don't want to have the data like this. So what I am planning to do? I am planning to take same thing. I wanted to partition. I wanted to have a partitions. Okay, I would like to have a partition. So this is my room. Room is there. Within the room, in the fact table, you can say room. I wanted to partition it. And here I wanted to keep all the blue balls. Okay, in this partition. I am not doing anything else. Same data is available there, but only I am segregating and keeping the data so that I can fast in doing the aggregations. So this is a blue, and I wanted to go for the red. Red balls I'm just keeping in this box, in this partition. Clear? So that is what I'm going to be doing now. Clear? So this is a red ball partition. So now I wanted to have a green balls in this. Now tell me what is the advantage when I partition the similar data in one box. Okay. Now after that, what I do? I wanted to label it, because if I keep something, nobody knows what it is inside, right? I'm going to be labeling as a, this is a blue ball box, and I'm saying this is a red ball, box, and this is a green ball box. I have to label it. That's it. So now tell me, if somebody asking me, tell me number of blue balls. What is the advantage? Now I can go to this partition and count 1, 2, 3, 4, 5, 6, 7, 8, 9. I can easily count. If you go back to the previous question, I wanted to know what is the blue ball. When you read, the ball could be red ball, red one, blue one, this one. We don't know. So every time you are very, very slow when you have the data like this. Sometimes I wanted to have, let us say, 2005 to 2010 data. Okay. So if I read a row, the road may be 2011 data. That data may be 2001 data. But I wanted to get the data of 2005, 2006, 2007. So you read the row by row, row by row, row by row. The row could be 2001 row or 2002 row. We don't know. Clear? When you store all the data in the fact table, because the fact table is heavy, don't dump the data like this. 2001 data, 2002 data. You have to partition the data. 2001 data, one partition. 2002 data, one partition. So you are going to be creating a partition. So I wanted to have 2000, one data, sales data here. Second partition, you're going to be having 2002 data. Third partition, you're going to be having 2003 data. So this is what we can have year by partition. But there is a rule. When is that you can go in for a partition? Per partition, you should have minimum of 2 million data. So that is what is the point here. Clear? To improve the performance of the queue, partitions are made always to the factor table. Points to note while creating a partition. On which column do we need to create a partition? I am talking about year column, right? Usually more frequently used columns must not leave any data. No record is pulled more than once. Volume per partition is minimum 2 million data. 1 million equals to 10 lakhs, right? So 2 million data. 2 million data you should have. For example, what is the data I have in my fact table? I will go to use Amazon.com. Amazon, this one, I wanted to know my fact table size. Okay. So let me go back. So, and count number of rows you need to have. Minimum partition. If you create a three partition, so you should have a much more data, but I don't have anything. 1600 records are available, but in the real time, you will have much more data. Clear? So you have to count by going to the data warehousing. What is the size of the fact table? What is the number of rows which are available in the fact table? Minimum one partition should have 2 million data. If you don't have that much of a data, don't go for a partition. If you have half a million data, 1 million data, complete fact table is having half a million data. Will you go for a partition? No. You are going to be going to the partition. If you have a 10 million data, 20 million data, 30, 40 million data, or hundreds of millions of data you have in the fact table, that is when you're going to be going to the partitions. Clear? So you have to know number of rows available in your data warehousing fact table. By executing this query, you can know, you will be able to understand the number of rows. Now I wanted to partition based on the based on what? Based on some column. So however you would like to partition, I wanted to partition the data year wise, or I wanted to partition data country wise. Where is the country here? You don't have country, but still. So we have a year number, sale date key, 2012, blah, blah, blah. So this is the location key. This is India data, one partition, America data, one partition, like that. Or you can have a product wise partition, customer wise partition, Indian customer single partition, American customer one more partition. However you wanted to create a partition, you can create. Clear? So that is what is the point you got to understand. What is the point? Partitions are done to the fact table only, because fact table where we're going to be doing aggregations, you have more and more data. Definitely it will give you a lot of issues. When you have all the data in a single fact table, we are going to be, keeping a lot of partitions. So first, to create a partition, you should know number of rows available in your fact table. To do that, we are going to go to data warehousing, and I've decided, so I knew that I have some 16 million data. Okay. Now the next one is on what basis I wanted to create a partition. I wanted to say year wise, sale date, year number. So what I do, I write where I'm going to be using a function called a left function. So column called sale date key, and I'll say 2012. It is going to be giving you 2012 data on only. Have you seen this? It is going to be giving you 2012 data. So I should have minimum 2 to 3 million data. I wanted to use a left function, four letters from left you read. So 2012, right? So I can get 2012 data like this, because I have lot of data coming from 2012, 2013, 2014. So I wanted to have year-wise partitions, okay? Because I knew that every year data is minimum 3 to 4 million data. I don't want to create data in a single fact table, create a partitions year wise. So this is the query I have to write it. Let me take Control C and Control V, 2013 data. Clear? And 2014 data. Or we can create a partition 2012 to 2015. So if that is the case, you can have lesser than, greater than, you can implement. You should be able to write like this. Okay. So what is that I'm talking about? I'm talking about uh, 2012 or 2013 or 2014, like that, or lesser than or equals to 2012. So whatever you would like to have it. Okay. So lesser than or equals to or greater than equals to. Okay. So greater than is equals to 2012 and lesser than equals to 2012 to, let us say, 2015. It is one partition. Okay. So 2012, 2013. So sorry, it is okay. So 2012 to 2014, 2013, 2014, like that, you are going to be creating one partition. So this is what is called this to that. Okay. So that is what you can have it, or you can also use between operator, between operator, right? If you're confused with this, between 2012 and 2015. So you can also use like this. Okay. So 2012 to 2015 data you can have. So again, the same clause you're going to be using 2015 to, okay, that's a 16 to, now I would like to have, let us say, 2018. 16, 17. For example, if you're getting so much of a data, decrease one, because partition is our choice. If you wanted to keep 1 year data, you can use 3 years data, you can use 5 years data, you can use, that is up to 20. That after that, 2018 to till date. Okay, 2020, probably maybe in 2018 to 2020, 2019 to 2020, like that. I'm going to be preparing 3 partitions based on the years. Based on the years, I wanted to have 2012 to 2012, 2013, 2014, 2015, like that. Okay. So between operator includes lower limit, upper limit, plus in between values. Remember, okay. 2012 data you can see, 2015 data you can see, in between data also, 13, 14 data also included. So what is the rule? No partition should not leave any data. For example, you say, I wanted to create a partition. Now you are leaving 14 data here. What about 15? 15 is not included, not included in this, not included in this. So you should not leave any data. That is the second point. See, must not leave any data. While creating a partition, you have to take all the data, must not leave any data. So here what I have done, 12 to 14 I have taken, but 15 I left it, and 16 and 18 and 20 and 19. Something like this I'm going to be implementing. So this will give you a lot of issues. You assume that you have data till 2020. 21 is not there because 2021 data may come December. So you should not leave any data, but according to this, I have left 2015 data, or I need 2015 data, 16 data, but this is writing like this. What is the meaning? 2015 data is available here, and 2015 data is also available here. Same data is pulled more than once. That is also dangerous. So that is the next point. No record is pulled more than once, right? You are writing wrong where clauses. So you are going to be getting 2015 data here, and you're also again, so if you go down and see, you can see 2015 data, right? Same data is also available there, because you're starting with 2015 data, because as I told you, between operator includes this. So no data is included in all the partitions, pulled more than once. No data must not leave, right? So that is also second one. If you're putting 15 here, either you can change to 2014, 14, 15, 16, 17, then 19, 20. That's fine. So this is how you are going to be creating a partition. I have used year-wise partition. Okay. So remember, you supposed to get a minimum 2 million data. You need to count. So number, you can put the count here and find number of rows in this partition. Clear, guys? So all these things can be done in the SQL server only. So I have 406 rows since I have limited data, but in the real time, so this is what we can do it. So I don't want to partition the data based on the year. I wanted to partition the data based on the country. We are having sales in India as well as in America. So how can I do that? How can I do that? So let me take the same thing, perform the country level or the location wise. Okay. Now I have a table called location table, right? In the location table, I wanted to know, I wanted to get country equals to India. I go to this table, right, where country equals to India. So I write the query like this. So what I'm going to get, I will be able to get all India. So what I need location key. I don't need anything. Copy with headers. Copy with header means you will get the column name. So these are the columns I would like to get it. So location key, these are India. So what I'm trying to do, I will take this query. I will take this query. I will go to this table. So where there's a location key here, right? So the same thing I can implement. So what I do, where the location key in, open the bracket and close the bracket. This is a subquery I'm going to be writing. So this will give me complete India data. Okay. So this is a subquery. This will get executed first, which will get the locations, the IDs of India, right? So it is going to be giving you this. Clear? Now I wanted to say this is India partition. I wanted to have a partitions of America, American, sales, America sales. So America means I have to give USA, right? So that is the thing. So this is the one. If you put store, if you put star, you will be able to get all this from USA. See, all these entries from USA. So all these location numbers from this one. So only I have to create like this and go back and just put this value. Okay. So two partitions are made. One is that USA only factor data need to be in separate partition. This is US data because I'm going to be getting location key of US. Clear? I'm going to be getting this one. So end of the day, we are going to be distributing or we are going to be partitioning the data based on the countries. This is also one more query you can write and you can implement. That is your choice. So whatever be the query that you are writing, you should know very well how to write and how to give the data. You may use a single factor table or you may use the dim location table in this table. End of the day, this data will get separated with the help of this where clause. You're getting only location key of USA, and because location key is available here, the country is available in this. I have written a subquery. Now, how do I do the partitions? Now you go. Now this is the partitions. Now you come to cube structure. This is the partitions, right? Now you go to sales. The entire sales table is here. Now I go to source. Click on the source. Now click on dot dot dot. Now this is where complete table is there. I wanted to write a query. I would like to write a query. The query is this query. I'm going to. This is nothing but star. This is nothing but star. Okay. So what is the query? The query we are writing is this query. Right. This is the query. I would like to create this data based on this. Copy this query and you simply paste it. Remove everything. And this is one partition I wanted to have it. Clear? So check. So syntax is fine. So you're able to include this query like that. You can create. So how to do? Very simple. Go to partitions, click on go here, dot, dot, dot. So go query binding. Now only this is a star. This is nothing but star, nothing. Okay. Simply you go put your where clause, this clause. So 2012 to 2014 data. Okay. So that's it. It is done. So this you need to say 2014 to 2018 data, right? No, 2012, sorry, 12 to 14 data. This is one partition. Clear? It's very, very simple. You can do the partitions. Now, after that, I wanted to have 15 to 18. So this is the one you should copy it always. Control C, go back. Next partition, you can click on this. First partition, you can click on that. Next one, new partition. Click next. So I would like to take the sales factor table and take this sales factor table. Click next. Specify the query. So go here. Control V. Now this is 15 to 18. Click next. Now click next. Now what is this? It is sales of 2015 to 2018, right? So design aggregations later. What is the aggregation? We'll see later. Click on finish. So this is second partition. Okay. So let me go. Third partition is copy. 19 to 20. Okay. Go back. New partition. Click next. And sales table. This is a factor table. Click next. Specify the query. Write the where clause. And click next. And click next. And you rename sales what 2019 to 2020. Design aggregations later. Click on finish. Like that, you should be able to create a lot of partitions. Clear? So this is the old data. This is the new data. This is the new data. Now I have created. After that, what should I do? I have to go here, build and deploy this. You have to build and deploy this so that whenever you wanted to, and one more thing I forgot, sorry. After creating a partitions, what we have done, we had labeled it because in which box you have a blue, you need to labeling, right? If you put sugar in a container, you need to say this is a sugar box. This is a some other soaps box. You need to label it. If you don't put the label, nobody knows what it contains, right? So you have to label. It is very, very important. Let me go to this partition and go to properties window. When you go to properties window, you will be able to get one label that is called this slice is what is this slice? This is a 2000, this is having 2012, 13, 14 data, right? So you go, you need to label it. When you open, when you go here, what kind of a data you have in this? In this you have 2012 data, comma, 2013 data, comma, you have 2014 data, right? So this is what is called a set. Clear? You need to say this is the labeling. So what kind of a data you have? So you have 2012, 13, 14 data that is available in this. Many people will ask you after partitioning, what you do? You have to label it. Label it means indexing. So this contains this data. This box is having what? Soap. This box is having pens. This box is having blue balls. Like that, you need to do it. So go to right click on this, go to properties, go to slicing. It's very, very important interview question. People would ask you after partitioning, what property, what is that a label that you need to do? You need to say slicing. Slice will index. So it is going to be containing 15, 16, 17, 18 data. So go here and open sale date and 15. Okay. Then 16 is very, very important step. Many people think that if they only do the partitioning, that is enough. That is not enough. Okay. You have to clearly tell them that this is going to be containing data of these years. Clear, guys? So this is what I can do it. The second slice labeling is done. It is what is called indexing. Slice property is very, very important. If you don't do this, then nothing will happen. Performance will not come, right? Because you have three boxes. Where the red ball, where the blue ball, where the green ball? How do I know? Until and unless I open and see it. I'm a human being. I have eyes and see it. But how a machine can see it? Machine will read the slicing values. Clear? So that's what is very, very important. It will go, you have to tell 19 and 20 data. 19 data, comma, 20 data. And this is a set. Why it is a set? Because same path is there. Clear? So once it is done, slicing is also very, very important. It is labeling the box. This box is having red balls. This box is having blue balls, something like this. You build them and you process them. Clear? So tomorrow what happens is that if you wanted to get only 2012 sales, it will go to this partition and reads the data. It is not going to open the complete data because it may be having some other data. So whenever you write any MDX query, what we are going to be doing, so it will be very, very faster. So automatically the proper partition is going to be taken. And it is going to be also very, very faster when you have large amount of data, because it is need not to touch the complete room. It will go to the appropriate room because you have labeled it. So 2012 sales I needed. Why should I go to every data? Go to that room and get only that data and show the data, something like this. Okay, so where I should go, that you need not tell. Automatically SQL SSAS engine is going to be opting the appropriate slice and going to that partition and getting the data from there. So that is the beauty about this. It is properly executed, and now you will get a lot of performance improvements. This is how you can do it. Now tomorrow, anyhow, this is 2012 is over, 14 is over. Tomorrow I would like to modify this. I wanted to include 21 as well. You can include 21 as well, because tomorrow you may get 2021 data as well. You can include, and you can label 20 this data also you wanted to include in this. Go here, Control C, 21 data also you may load tomorrow. Clear? So that is one. You can rename this. Go and rename this, and that's it. So when you're adding a new data to the data warehouse, the new data will come to this partition. It will not come to this partition. So why should I aggregate a complete cube? If I wanted to aggregate a complete cube, what will happen? All the data will be removed from the cube database. Again, reading all the data from the data warehousing and doing aggregations on all the data. It will take 5 hours, 10 hours. So why should I waste my time? Because anyhow, I am not going to be modifying this data. I am not going to be modifying this data. Only I am modifying this data because 2021 data every monthly, every quarterly, I'm pushing it. So only the data aggregations will change in this. So what I do, I can also aggregate. I can also aggregate. I can also process the partition level. Go to process. I don't want to process complete cube. I wanted to process only the partition. Clear? Because already there is no change there. If there is no change of data there, why will I go and again do the complete cube processing? So I don't want to do that. So I am going to be doing only the process of this one. So something is failed. I don't have this data, because of it is failing. Clear? If you don't have the corresponding values, it is going to be failing. Clear? So I don't want to, I did not exported the data of 2021. So because of that, it is failing. So it may remove that. So you need to have the data. Remember that. Without that, the cubes will fail if you don't have the data. Let me go and slices also. I have to remove it because I don't have this data at all. See now, do we have 2021 data? It is not there, but it is telling me this year. So because of that, I'm getting this error. If you have the 21 data, there is no issue. You can also go and process individual partitioned data. Clear? So many a times you don't partition whole cube. Whole cube means what? Dimensional data part you're processing, this data you're processing, that data you're processing. That is always waste of time, right? So we can also go in for partition level, and sometimes fact data will not get modified. Only dimensional data will get modified. So sometimes we can also process only this dimensional data. I don't want to, for example, a dimensional table is, getting the lot of data, but there is no change in the fact table. So why should I process the complete cube? I can go and process only that dimensional data. Clear? So from the data warehouse, the data will get dumped onto the cube database. Clear? So that is the understanding of processing of a dimension, processing of a cube, and the processing of a fact, the partition of a fact. Clear? Because if you do the complete processing, it will take 10 hours, 12 hours. So I don't want to do that because I have to modified some steps in the dimension level. So I wanted to process only my dimension. So that is how you can improve at the processing level as well if you have a partitions and everything. Am I clear, guys? So this is what is called cube partitions. Now, if you observe carefully, so this is what I have done: query binding and the fact and current server, blah blah blah. I have given this data. Now, this is the thing I have added there. Now, slicing is very, very important. This is what I told you. Many people, after creation of a partition, if you don't slice, then it will not use the proper partition. It is again going to the complete, factor table, searching for the data. Clear? Because it does not know which box has which kind of a data. I told you, right? This is a blue box. This is a red color box. So that kind of a labeling is important. The labeling we discussed it. So this is what is called labeling. This slice is this one. This slice is this one. Something like that. Clear? So that is what. So next one, storage modes in the cube. This one we'll discuss tomorrow. It's very, very, very important and a question. So when you go here, there is a storage mode. If you see clearly, there is storage mode. Okay. What is this mode? Let us understand. So this is a small setting here, storage settings. So this is what we need to click on. So I go here, I click on storage settings. Clear? So I will be able to get few things. One is called mole app, whole app, and a role app. Okay. So these are the three things that you got to understand. Okay. What is a mole app? Mole app means multi-dimensional OLAP server. Whole app means a hybrid OLAP server. Okay, role app means real time or relational OLAP server. Clear? So OLAP servers are three types. OLAP servers means I'm talking about a cube database. Cube database I'm talking about, right? So cube database servers are three types. One is called MoLAP. Second one is called whole app. The third one is called role app. Clear? So this is what is called storing settings. Very, very important stuff. This will discuss tomorrow. Clear, guys? Any questions you have? So storage modes. What are the storage modes? These are the storage modes we have. One is called MOLAP, multi-dimensional OLAP server. Role app, relational or real-time OLAP. OLAP means we know online analytical processing system. OLAP means a hybrid OLAP. Okay. So when to use what? By default is MOLAP. MOLAP means multi-dimensional OLAP. That is the default mode in the cube. So when you go back and see, all these partitions are going to be storing the data in this format only. What is this, and why we need to use this, and what are the advantages, disadvantages, everything we'll discuss tomorrow. When you click on this, so you can adjust. For example, I wanted to go in for this mode, you can go in for this mode. If you want to go in for this mode, whatever you would like to have it, you can have it this. So tomorrow we'll see these settings. You can change if you want to change it here. Okay, you cannot change directly here. You need to go. You need to select this and click on this and change the setting mode. And we have a couple of options. So these options also we'll see them tomorrow. Clear, guys? So this is what is called partitions. Why partitions means to improve the performance of the cube, right? So at the time of processing also we'll have less time. At the time of aggregating the data, or whenever you write MDX queries, it is going to be going to the appropriate partition and bringing the data so that it is very faster. So if you store the blue balls in this box, so I can simply go here and do the aggregations on this box, right? So instead of storing all the data in a single, factor table, so always the factor tables are partitioned and not the dimension tables. Clear? So fact table, when you have it, always fact table will go appropriate customers and everything, because you have primary keys and foreign keys. You have a linkages, right? So always this 2001 data of a given customer, given date, given product, it is going to be going and bringing the data from the dimension table as well, because you have a product key, this key, that key, all of them are primary keys and foreign keys. For the remaining data, it can go to dimensional table and get the data. We are going to only partition the factor tables, not the dimension tables. Clear? So what is the rule? Minimum 2 million rows you have to have it. Otherwise, don't think about partitions. If the factor table is having a 10, 20 millions of rows, then you can decide, let me have 4 million data, minimum 2 million. You can have 4 million, 5 million per partition. Clear? So all these things are important, guys. So tomorrow we'll discuss about storage modes. Clear? And you will get a new meeting ID tomorrow, guys. Please, ask my team. They will send you. If you don't get it, and ask my team or ask me. Okay. So we will have new meeting ID from tomorrow. Thank you, guys. Bye bye. Any questions?
Uh, Sir, one
Hmm.
question.
Hmm.
In the real time, we used to have partition on our LC, infect table, right? In the data warehouse. So
What table?
suppose we
Fact
have
table.
a partition on, yeah,
Hmm. Hmm.
uh, yeah. So if we have already partition available on data warehouse tables, and we want to create partition on the cube level, so what
Hmm.
should be our strategy for that?
No. Database level partition, you should not think about, because we are talking about the cube level partitions only, right? Anyhow, database partitions will be there to improve, OLTP data warehousing. So that is not included here. That is something different. This is something different. It is for the queue processing, right? For example, if you have a problem, you need to get the medicine, and somebody else in your family also getting a medicine, that you cannot include it here. So we are talking about large amount of data. You have it where? In your cubing level, right? So cube will get slow because of it does not have proper data to look up. If you have a partitions at the SQL Server level or in the Oracle level, so that is not going to be impacting anything. This is something different, because anyhow, factor tables are partitioned by default in RDBMS level. Remember that. Clear?
Yes.
Yeah. So that is nothing to do with this partitioning.
Okay.
Yeah. Very good question. Anything else? Okay, guys.